Let's learn how to graph sine and cosine. Here we have a sine wave. You'll see what I mean. On our agenda, we're going to graph the parent of the sine graph along with its transformations, the parent graph of the cosine graph with its transformations. There's lots of new graphing vocabulary, and we'll compare the graphs of sine and cosine. Let's get ready. You're going to need your notes and a pencil. And here's our unit circle. We're basically going to unwind this circle as we try to figure out the y values for sine of x. So when x is 0, right here, that's our starting point, y is also 0. Pi over 6, we know that the sine is the y value. It's the height of our triangle. This is our little triangle, so it's 1/2. Pi over 4 is our medium triangle, so it's our medium fraction of root 2 over 2. And pi over 3 is our tall triangle, so we're looking at root 3 over 2. When we're at pi over 2, that's our quadrantal angle, so our point is 0, 1, and we want the y value, so it's 1. And then coming down the other side, we start at the tall triangle, so we are, again, root 3 over 2. Medium triangle is root 2 over 2. Small triangles 1/2. And in this quadrant, y is also positive. So notice that sine for all of those were positive. Now when we look at the sine of pi, that means we're all the way over here, and it's going to be 0 again. 7 pi over 6 is down in the third quadrant. Going down means that my y value is negative. So these sine values are going to be negative. So this is my little triangle, so it's my little fraction, negative 1/2. 5 pi over 4 is my medium triangle in the third quadrant, so it's negative root 2 over 2. 4 pi over 3 is my tall triangle, negative root 3 over 2. 3 pi over 2 is my quadrantal angle, so now we're down at the bottom with a negative 1. 5 pi over 3 is negative root 3 over 2. My medium triangle in the fourth quadrant is my medium number with a negative, and we have negative 1/2. It brings us back to 0. So we have 16 values there, and when we're try to go ahead and plot those. So we're graphing sine of x. We're at 0, 0. Pi over 6 and 1/2 is probably about there somewhere. Pi over 4. These are not even increments, somewhere around there. And pi over 3. And then 1. And then we're going to come back down, try to make it a little bit symmetrical, and then pi is 0. And then negative 1/2, and a little bit bigger to negative 1, and we're back to 0. So when you graph these do come from our quadrants. This is the first quadrant up to pi over 2. So this is a quarter circle. So draw it like that. It will make your curve look a little better. And then this is a quarter circle. And this is a quarter circle representing quadrant 3. And this is a quarter circle representing quadrant 4. And that is one cycle of our sine graph. So we don't need to graph all 16 points every time. We can use the 5 key points. Those are going to be my 3 x-intercepts and then the values in the middle when you cut that in half. So I'm going to go to 0. I know that my period, the full length, is 2 pi, so I'm going to put 1 there. I'm going to cut that in half, and I have another x-intercept in the middle at pi. Then in between those, I cut that in half. I'm at pi over 2. And the sine of pi over 2 is 1, so I'm up at my max. And then the sine of 3 pi over 2, I'm down at the bottom of my unit circle, which is a negative 1. And we're just going to graph like that. So you can use the 5 key points. The highest is going to represent your max. The lowest is your minimum. Keep remembering that this goes on forever, so you're going to have lots of max and mins. And some of our vocabulary. So we said that this was the max. The bottom is our min. Our amplitude is the max minus the min divided by 2, and it's always positive. It's representing a height, so it's positive. Or you could do the max to the midline. In this case, it's 1. So my amplitude here is 1. My x-intercepts, we know are where it crosses the x-axis. And the midline. Oftentimes, I'm going to dot in the midline. It's not an asymptote. It's just going to help me line my line my points up, especially when I start to move them. And then the period is the length of one cycle. In this case, our period is 2 pi. For the transformations for sine, we may see the equations in two ways. So we have added the letters A, B, H, and K. But if you look carefully, in the first one, I put B inside the parentheses, and the second equation, I put B outside the parentheses. It is going to change how you choose your H, that's all. It is easier if B is on the outside. So A is our amplitude, B is our frequency. It's going to help us find our period. The B does not tell us our period, but it helps us find it. It's this little formula that period equals 2 pi over B. So if B was 2, then we do 2 pi over 2, and I know that my period is pi, and now we've shrunk it a little bit. In the first equation, we have to do H divided by B. In the second equation, it would just be a shift of H. And this is a new vocab word. We usually just say horizontally shift, but when we talk about trig, it's a phase shift. So we have a phase shift that's going to shift left or right. And then the plus K, like all of the others, is going to shift it up or down. In this case, it's going to move that midline. So let's try this example. My amplitude is A, so I know that I have an amplitude of 2. My period, well, there's no B written there, so it's an assumed 1. And if it's 1, then my period is going to be 2 pi, which means I'm going to graph a cycle of 2 pi. My phase shift left or right is going to go to the right, pi over 2. And my vertical shift is going to go up 3. So I'm going to start with my coordinate plane. I like to start with my shift up. And that is the midline. Again, not an asymptote. From there, my amplitude is 2, so that means I'm going to be up at 5 and down at 1, and my graph is going to be between that. I like to draw these dots so I can keep all of the max and mins at the same height there. And now we are shifting to the right, pi over, oops, I wrote pi over 3, pi over 2. So I'm going to go ahead and draw pi over 2, pi, 3 pi over 2, 2 pi. I know I'm going to have to go another pi because I'm shifting, so that would be 5 pi over 2. So normally I'd be at 0, 0 with my sine. So I'm now going to move up 3, and I'm starting there. I'm going to go to the right pi over 2. That's my starting point. From there, I'm going to go a full cycle, which is 2 pi, so I want to make sure I have a length of 2 pi. I'm going to cut that in half, so I'm at 3 pi over 2. Now I want to go back and cut that in half, and that puts me at pi. So I have a maximum at pi over 5. Cut this one in half, so I have a minimum at 2 pi comma 1. And then I draw my quarter circles for my sine graph. All right, our amplitude here is 3. Notice B is on the inside and B is 2. So if B is 2, that means I'm doing 2 pi over 2, which means my period is going to be 1. My phase shift, be careful, it's not just pi. This is going to go to the right, pi over 2. And then vertical shift, there is none. So we're going to keep our midline at the axis. So I'm going to go to the right, pi over 2. I'm going to draw everything kind of to the same scale that I did last time, so we can purposely see that shift. My amplitude is 3, so I'm going to be up at 3 and down at negative 3. And I'm going to the right, pi over 2. So that's my first point. My period this time is only pi, so I'm just going a distance of pi, which would be right there. I'm going to cut that in half, and then I'm going to cut those in half, and I'm going to be at my max and my min, and then we have our sine graph. So you can see that it's squished. It has the period that's only pi long. Let's switch over to cosine. We'll complete our table of values for cosine of x. The cosine of 0, oops, I did this wrong, darn it. How did I do that wrong? 1, 0. When x is 0, when x is 0, we're up here at 1. pi over 6 cosine is root 3 over 2. Pi over 4 is my medium triangle. Pi over 3 is 1/2. Pi over 2 is 0. The cosine of 2 pi over 3 is root 3 over, negative 1/2. Let's get rid of that, negative 1/2. I'm looking at my x's. Negative root 2 over 2, and we would keep carrying these numbers down. I am in the second quadrant, and cosine is negative. And we have negative 1. I'm in the third quadrant, so cosine is still negative. I'm at the bottom, so cosine here is 0. And then we're in the fourth quadrant, so these are going to be positive values. And then that's going to bring us back to 1. So when we go ahead and graph it, cosine starts up at the maximum. It's going to be at 0, 1. And we could go ahead and graph all of these, just a little bit of guessing. And then we're at 1/2, and then we're at 0. And then I'm going to go here and come down a little bit, go here, and I'm going to end up there. And again, turns of a circle. So there's a quarter, a quarter, a quarter, and a quarter for our cosine graph. You don't need to graph all 16 again. You can do your 5 key points with your x-intercepts and your maxes and mins. So we're going to do a transformation here. My amplitude is 5. My period, B, is 1, so my period is 2 pi. My phase shift, this time we're going to go left pi over 2. And we're going to move this down 1, which is going to shift my midline. So I'm going to go down 1. Make that my midline, that's negative 1. From there, I'm going to go down 5 more. So we're at negative 6. I'm going to go up 5, which puts me at 4. And my graph will be between there. We're going left pi over 2. And I will do my other marks. And I'm going to use my 5 key points. So I know that cosine starts up at its max, so I'm at negative pi over 2, 4. Then I'm going to go 2 pi away, so I'm going to be at another max at 3 pi over 2. I'm going to cut that in half at pi over 2, and I'm going to be at my min. I'm going to cut that in half, and we're at the origin, cut that in half, and I'm at pi 0. And there's my cosine graph. Well, let's try this one. My amplitude is 2. Yes, I know it's negative, but that just means we're going to reflect it. My B is 1/2, so this becomes 2 pi over 1/2, which is 2 pi times the reciprocal, which is 4 pi. So this is going to be stretched out. My phase shift, there is none. My vertical shift, there is none. So let's take a look at this. And I'm going to go pi like that. My amplitude is 2. And I do have to remember that I have to reflect it. So normally I would be starting up at 2, but I'm going to start down at negative 2. 0, negative 2. I'm going to go to the end of my period, which is 4 pi. I'm going to cut that in half, which is 2 pi, and I'm at max. Cut that in half, but I'm at my middle and my middle for my 5 key points of this reflected cosine graph. So here is the red graph of cosine and the blue graph of sine. What do you notice? They look very similar. It really is just a phase shift. It's a phase shift of pi over 2. So if I took the red graph, which is here at pi over 2, and I moved it to the right, pi over 2, then I would have the red would become the blue. That's the only difference. The midlines are the same, the period is the same, the amplitude is the same. So for your transformations, your A is your amplitude, Your B is your frequency that helps you figure out your period. Your phase shift is left and right. Your K is your vertical shift, which will move your midline. And divide by your period by 4 to use those 5 key points. Good job.